12 chickens. That is what the average family needs to produce reliable protein year-round. Coop construction, daily feeding, weekly cleaning, and at least $40 monthly in feed costs. Every egg represents work. Now picture something different. A single system the size of a kiddie pool. 5 minutes to set up. No feed to buy, no coop to build, no predators to guard against. And every 48 hours, it replaces what you harvest. NASA calls it the most protein-dense plant on the planet. The Thai call it eggs of the water. They have harvested it for centuries, while Western agriculture ignored its existence completely. Two things explain why you have never heard of it. One involves water. The other involves an industry that profits when you cannot grow protein yourself. By the end of this video, you will have the exact setup that turns any container into a continuous protein factory. But first, you need to understand what has been hidden from you and why. For generations in northern Thailand, families have harvested tiny green spheres from still water. No farm needed, no fertilizer purchased, just a wooden bucket and patience measured in hours, not months. They called it kainam, eggs of the water. The plant floated on calm ponds and drainage ditches, requiring nothing but sunlight and nutrients already dissolved in the water. Yet it provided something that should have been impossible: complete protein, every essential amino acid. Growing faster than anything Western agriculture had ever seen. The knowledge passed from grandmother to grandchild. Harvest in the morning. Serve it in omelets by noon. The pond looks full again by sunset. Then Western science finally noticed what indigenous communities had known for centuries. Dr. Barbara Demig Adams at the University of Colorado Boulder began studying a plant so small you could fit dozens on a single fingernail. When NASA needed food for long-duration space missions, her lab provided the answer. The same plant was growing wild in American ponds, floating unnoticed within miles of major universities. The same protein source Thai grandmothers scooped from buckets became the centerpiece of space nutrition research. We imported protein from across oceans while it grew in our backyard drainage ditches. Now let me show you the numbers that do not make sense until you see them yourself. Researchers publishing in Food Chemistry in 2017 measured duckweed protein content ranging from 20 to 45% dry weight. For comparison, beef contains about 26% protein. Eggs sit around 13%. Soybeans reach 36% on a good day. A 2024 study in the Journal of Agricultural and Food Chemistry found one species called Lemna gibba reached 45% crude protein, higher than beef, triple the concentration of eggs. The amino acid profile is complete. Every essential amino acid present, meeting or exceeding World Health Organization requirements for human nutrition. The protein digestibility score rivals egg white, the gold standard for protein quality. Most of this protein is rubisco, the most abundant protein molecule on Earth, the same enzyme that allows plants to convert sunlight into food, concentrated into something you can eat directly. Here is where it gets strange. Current Biology published findings in 2023 that made researchers reconsider everything they thought they knew about plant growth. Under favorable conditions, duckweed doubles its biomass clonally in 48 to 72 hours. A 2025 paper in Scientific Reports described it as approaching what scientists call the Darwin-Wallace demon, the theoretical organism that reproduces as fast as mathematically possible. Ziegler and colleagues measured doubling times as fast as 1.34 days. Some strains approach 16 hours under perfect conditions. Picture this. Day 1, you place a thin green film on still water, barely visible, just scattered dots smaller than lentils floating on the surface. Day 3, a carpet so thick you cannot see water beneath. Day 5, you scoop out handfuls and the container looks exactly as full as before. The plant replaced itself overnight. Compare this to anything else you might grow for protein. Soybeans need 90 days minimum. Beef cattle require 18 months to reach slaughter weight. Duckweed doubles before most people remember to water their houseplants. Now here is where conventional agriculture falls apart completely. A 2024 compilation in Science Direct gathered yield data across multiple studies. Duckweed produces 2,080 kilograms of protein per hectare per year. Soybeans produce 303 kilograms. Corn produces 179 kilograms. That is not a marginal improvement. Duckweed yields nearly 7 times more protein per unit land than soy, 10 times more than corn. ACS Food, Science and Technology reported even higher numbers. Under optimal European greenhouse conditions, duckweed yields 10 to 18 tons of protein per hectare annually. Soy in the same region produces 0.6 to 1.2 tons. One researcher summarized it simply: the surface of a small pond can outproduce an entire soybean field. The environmental comparison destroys every argument for industrial protein production. Food and Bioprocess Technology published data in 2025 showing duckweed produces 0.4 kilograms of carbon dioxide equivalent per kilogram of plant material. Beef produces 27 kilograms of carbon dioxide equivalent. That is nearly 70 times the climate impact. Duckweed requires no tractors, no pesticides, no competition for cropland. It grows on water that would otherwise sit unused. It thrives on agricultural runoff, fish waste, even treated wastewater. Instead of creating pollution, it absorbs it. Instead of depleting soil, it floats above the surface. Instead of requiring irrigation from stressed aquifers, it lives in the water itself. A plant this productive, this efficient, this accessible should be growing in every backyard in America. So why did this knowledge disappear from Western awareness? 3 reasons compound each other. First, it looks like pond scum. Western agriculture values appearance and scale. The visual spectacle of a cornfield draws investment. A plant you need a magnifying glass to appreciate does not photograph well for farm subsidies. Nobody brags about their floating green carpet the way they brag about their tomato harvest. Agricultural publications feature golden wheat and orderly rows. They do not feature microscopic spheres smaller than rice grains floating on still water. Second, it cannot be patented in its natural form. No seed company profits from something that reproduces by splitting in half. No equipment manufacturer sells specialized duckweed tractors. No processing facility stands between you and your food. Every middleman in industrial agriculture loses money when you grow protein in a bucket. There is no recurring revenue in a plant that replaces itself every 48 hours from what you already harvested. Third, the industrial food system depends on complexity. It requires long supply chains, storage infrastructure, processing facilities, and distribution networks. A plant that grows itself in any container with water and sunlight threatens the entire model. Food independence is bad for business when business depends on your dependence. But in Thailand, this knowledge never disappeared. They call it Kai Nam, eggs of the water. The genus Wolffia has been part of local cuisine for centuries. Served fresh in omelets, stirred into soups, sold in morning markets like any other vegetable. It was such an obvious protein source they never needed to rediscover it. Dr. Wayne Armstrong spent decades documenting every duckweed species on Earth. He found Wolffia globosa growing wild within miles of major American universities. The same plant Thai grandmothers harvest, floating unnoticed in American ponds, hidden in plain sight. Then space travel changed the equation. NASA needed food that grew fast in confined spaces with minimal resources. Suddenly, duckweed mattered to people with funding. The Translational Research Institute for Space Health partnered with the University of Colorado Boulder. Dr. Barbara Demig Adams and her team published findings that confirmed what traditional knowledge had preserved for generations. Duckweed is the most protein-dense plant on the planet. It produces radiation-fighting antioxidants called zeaxanthin and lutein. It thrives under artificial light at half the intensity of natural sunlight. NASA tested it on suborbital flights through Blue Origin. The same plant dismissed as pond scum became the centerpiece of Martian food research. What grandmothers knew for centuries became a venture capital darling overnight. Now I promised you the 5-minute setup. Here is exactly how to do it. You need any container that holds water. A 5-gallon bucket works perfectly for starting. A plastic storage bin works for modest production. A 50-gallon stock tank feeds a family. Even a glass baking dish on a windowsill produces measurable protein. Choose shallow and wide over deep and narrow. Duckweed only grows on the surface. 3 inches of water depth is plenty. More surface area means more growing space. A kiddie pool outproduces a rain barrel every time. For water, you have options. Dechlorinated tap water works fine. Let it sit overnight in an open container, and the chlorine evaporates naturally. Rainwater works even better. Pond water is ideal if you have access. Add a few drops of water conditioner from any pet store if you need to start immediately. The pH should fall between 6 and 7.5. Most tap water already sits in this range. Do not overthink it. Nutrients matter, but not as much as you fear. Fish tank water is perfect. The nitrogen from fish waste provides exactly what duckweed craves. If you do not keep fish, dilute any balanced liquid fertilizer to 1/5 the strength recommended on the label. A few drops of aquarium plant food each week maintains growth. Even a single decaying leaf provides enough organic matter to sustain a starter colony. Compost tea works beautifully. Steep finished compost in a bucket of water for 24 hours and pour a cup into your growing container weekly. Now the duckweed itself. You can find it in local ponds during warm months. Order it online from aquarium suppliers. Get a handful from anyone who keeps fish. 1 tablespoon is enough to start an entire bucket. Float your starter culture on the surface covering 10 to 20% of the water. That is all. Place your container where it receives bright indirect light. 6 hours minimum. A sunny window works. A shaded patio works even better. Experiments have shown duckweed often grows faster in partial shade than full sun. Direct blazing sunlight all day can overheat the water, but duckweed tolerates more variation than you expect. Temperatures between 60 and 90 degrees Fahrenheit keep it thriving. That is the entire setup. Walk away. 48 to 72 hours later, the coverage has doubled. You will not believe how fast it happens until you witness it yourself. By day 5, you can harvest. Skim half the surface with a small net or kitchen strainer. Leave the other half to keep multiplying. Rinse what you collected. Pat it dry. Eat it fresh in salads or blend it into smoothies. Spread it thin on a tray to dry for protein powder. Store the dried powder in airtight containers indefinitely. One critical warning: never dump duckweed into natural waterways. Some regions classify it as potentially invasive. Compost any excess instead. Feed it to chickens and watch their egg yolks turn deeper orange within weeks. Tilapia farmers have cut feed costs by 50% using duckweed. Every animal that eats plants benefits from this protein source. Here is what the industrial food system never wanted you to understand. Protein independence requires neither wealth nor acreage, nor permission from the corporations that profit from your dependence. The solution floated on every neglected pond and forgotten drainage ditch all along. The same plant Thai grandmothers have harvested for generations. The same protein source NASA researchers selected for feeding astronauts on missions to Mars. It was hidden in plain sight. 1 container, 5 minutes. Continuous protein production that replaces itself faster than you can harvest it. The Thai grandmother knew. NASA scientists know. Now you know. If you found this valuable, subscribe and watch the next video. The system that controls your food supply is not prepared for what happens when you opt out.